Understanding reinforcement learning. A fun analogy. Imagine a puppy learning a new trick. You want to teach the puppy to sit. Every time the puppy sits on command, you give it a treat. When it doesn't sit, it doesn't get the treat. Over time, the puppy learns that sitting down when you ask leads to a tasty reward. This is how reinforcement learning works. Reinforcement learning is like teaching your puppy, but instead of a puppy, we have intelligent computers. These computers learn by interacting with their environment. Imagine the environment as a big playground for the computer. It tries different actions to see what happens. If an action leads to a good outcome, like getting a treat, the computer remembers that. It tries to do those good actions more often. If an action leads to a bad outcome, no treat, the computer learns to avoid that. This trial and error process helps the computer become really good at solving problems and making decisions, just like our clever puppy. Let's break down reinforcement learning into its main parts. First, we have the agent. The agent is like the learner or the decision maker. In our puppy example, the puppy is the agent. It's learning to perform the trick. The second part is the environment. This is the world or situation that the agent is interacting with. For the puppy, the environment is your house and you, the trainer. Lastly, we have actions. Actions are the things the agent can do within the environment. The puppy's actions include sitting, barking, or wagging its tail. The agent chooses actions to get rewards from the environment. Reinforcement learning is used in many cool technologies. Video games use it to create challenging opponents. The computer learns your moves and strategies, making the game more fun and unpredictable. Robotics also benefits from reinforcement learning. Robots can learn to grasp objects, move around obstacles, and even assemble products in factories, all thanks to reinforcement learning algorithms. Self-driving cars are another exciting application. These cars use reinforcement learning to navigate roads, obey traffic rules, and avoid accidents. This technology promises safer and more efficient transportation in the future. Even your smart home devices can utilize reinforcement learning to understand your preferences and automate tasks, making your life easier and more comfortable. Reinforcement learning has the potential to revolutionize many industries. As computers become better at learning from experience, they can help us solve complex problems and make better decisions. However, there are still challenges. Reinforcement learning requires massive amounts of data and computing power. Researchers are constantly working on making it more efficient and accessible. Reinforcement learning is shaping the future of technology. It's already making our devices smarter, our games more engaging, and our world more automated. What are your thoughts on the potential of reinforcement learning? Let's discuss.